Hey, I'm Will Button, and welcome to Day 2 of Blockchain Application Development in 7 days. Well, yesterday we got our development environment set up, and we learned about the tools that we're going to use in this course. Today, we're going to learn about the variables in the Solidity programming language. We'll cover what they are and how they're used. If you're new to programming in general, this is a key concept to master. If you're an experienced programmer, there's still some valuable tips in this lesson, as we're going to cover some of the nuances particular to variables in Solidity. Solidity is a statically typed language. This means that when variables are declared, you must state the type of variable that it is. In this example, we're declaring an unsigned integer with the name of foo. We set its visibility to public, and we'll cover the different types of visibility in just a minute. We can optionally assign it a value, and then we end the statement with a semicolon. Compared to JavaScript, you might see foo declared with let, and you also might see it declared as a constant. And if you're looking at older JavaScript code prior to ECMAScript 2016, you can even see var foo equals 4. In the next video, we're going to cover all the common types available in Solidity in detail, but for now, let's focus on what this visibility identifier means. All state variables in Solidity must have their visibility declared, and there are 4 types of visibility. There's external, public, internal, and private. When the visibility is declared as external, it means that the variable or function becomes part of the contract interface. This exposes the function or the variable so that it can be called from other contracts and transactions. For example, if we have a function in our smart contract that determines whether the player of our game has won or lost this round, we need to call that from a React application. So it needs to be external because if you remember, our React application lives on our web server, but our smart contract lives on the Ethereum network. Like the external visibility, state variables and functions with public visibility are part of the contract interface, and they can be called from other contracts and transactions. They can't be called internally without using the keyword this, and an automatic getter function is created for all publicly declared variables. But what does that even really mean? It can't be called internally without the keyword this? We'll take a look at this. If we have a function in our contract, foo, that returns the string hello, from within that same contract, calling the function foo directly is going to fail. If we want to call it, we need to call it as this.foo. Internally declared variables and functions are only accessible internally from the current contract and the contracts derived from it. Using our same example, if we change the visibility of our function foo to internal, calling that function directly without the this keyword now works. And private functions are very similar to internal functions. They're available within the current contract, but they differ in the fact that they aren't available in contracts derived from this contract. It's really important to note, though, that that doesn't mean your code in private state variables and functions is private. It just means it can't be called. Everything on the Ethereum blockchain is publicly viewable. To drive that point home, using a tool like Etherscan, I can view the source code for a popular dApp like CryptoKitties and see all the source code, including the private functions and variables. Earlier I mentioned that state variables declared as public will have a getter function automatically created. So this is done as a time-saving feature. After all, you've declared your variable as public. You probably have the expectation that your clients are going to need to access the value of that variable at some point. So that you don't have to spend time and energy creating that getter yourself, the Solidity compiler is going to create one for you. For example, if we have a contract named A that declares a public variable foo, any transaction or contract can get the value of that variable by calling a.foo. You didn't have to write any code for this to work. The compiler just did it for you.